as many of you have found out, if you do what I ask you to do and you watch the videos and you follow what I'm doing in the videos, and then you come to the live lessons, you can have a good grade in this class. Even if you're not understanding things completely, you can still pass by just doing the work that I'm asking you to do and getting it turned in on time. For those of you who on the quiz, I'm gonna tell you, I made a mistake when I assigned the quizzes, because there was a first period quiz and there was a second period quiz. What I did by mistake was I assigned both quizzes to everybody. And so if you saw where like you were missing the quiz grade, but you knew you had done the quiz, that's why. And so I went back and fixed that yesterday when I realized it. A parent emailed me and said, hey, my son did this quiz, and and I was like, oh, wait a minute. Yeah, I know he did because I gave him credit for doing it, but I realized that it was the other class's quiz that he was seeing that he hadn't done. So anyway, if that happened, I apologize, but I fixed it yesterday. So anyway, this is Unit 2, exponential functions, and then we have what we call log functions. These two are inverses of each other. And we talked about inverse functions last Thursday, I think, and we went through them, how to find an inverse. And today we're going to talk about exponential functions, and we're going to talk about how to find the inverse of exponential functions and how to find the inverse of what we call log functions. Just want to go through a couple things that are pretty much review, or should be, first, and that is at the beginning of these notes we have a question: determine how many times do we have to multiply 2 by itself, I should say by itself, I think, to get 8. In other words, 2 times 2 times 2 is 8. And of course we use an exponent to write that. We would write 2 to the 3rd power equals 8. So the number of times that we have to multiply, what they're asking for is, what is the exponent that we would use to get 8 from 2? And we would use a 3. Well, what about if we were trying to figure out 16,384? That wouldn't be so easy, because to try to put that in a calculator, I don't even know how many times it is. I've never figured it out. But to try to put that in a calculator, we would have to hit 2 times 2 times 2 times 2 and then see how many times it was. But there's actually an easier method, and it's what we call logarithms. So that's what goes here. The easier way to figure this out is to use what we call logarithms. We also call these just logs. So an exponential function is one where the exponent is the unknown. So the x right here is the unknown. So something like, I'm going to write this up here. You don't have to write this part. So something like y equals x squared plus 3. Even though this has an exponent in it, that's not what we call an exponential function. This is a quadratic. This is a parabola. An exponential function would be something like y equals 2 to the x power plus 3. So this is exponential. This is quadratic. So we don't want to get those confused. Quadratics we do in Math 2. And those are parabola again. But exponential functions don't have the same look as quadratic functions. So you might see something like b to the x equals a. Now b and a would be numbers, and I'll give you an example. If you had something like 2 to the x power equals 8, well, that's an exponential equation. That's an exponential statement, okay? If I had y equals 2 to the x, that is an exponential function, and the log function would be the inverse of that. 2 to the x equals 8 could be written another way. It can be written using a log, and what we would do is we would write log, the word log, and then we would put a little 2 down there. That's what we call the base, okay? And then we would put the 8 right here equals x. So this is just how you rewrite an exponential statement and make it a log statement. You're going to have to know how to do this, and we're going to practice this in a minute. But you'll have to know how to do this in order to find those inverse functions, okay? On the other hand, if you have something like x equals log base b a, I actually like to write this the other way around. I like to write it with the log part on the right. Well, let me get my highlighter here. So over here, the base was 2, which goes here, okay? The exponent is x, and that's going to be rewritten right there. And then I don't really know what the technical term for that 8 is, but that goes right there. So same thing over here. The exponent, and I'll color it the same color, is right there. The base, which I did teal, is here. And then the other part that ends up being the answer, or to the right of the equals, is right here. So to go the other way around, to change a log statement to an exponential statement, we would write b, and we just kind of go in a circle. It's b to the x power, b to the x power equals, and then it's going to be that right there, a. Now we're going to practice some of these with actual numbers, but I'll put one right here too. If we had like log base 3, and then an 8 right here, and then an x right here, what we would do is to rewrite this in exponential format, we would do 3 to the x power equals, this is kind of a circle, equals 8. So that would be exponential. On the left would be log form. So if you're asked to take an exponential statement and rewrite it in log form, that's how you do it, and vice versa. It's important to note that these two types of statements, or these two types of functions, are inverses of each other. So when we talked about inverses last week, these two are inverses of each other. And the reason is, when we're talking about doing inverses, we had to like undo stuff that had been done to the left side of the equation, or the right side of the equation, or whatever, when we were trying to get y by itself, and we're going to do some of those too. We can't do that when the exponent is the unknown. So we have to use logs to write inverses of exponential statements. Let's practice a couple of actually, let me show you this first. And then we're going to practice rewriting stuff. Okay, so exponential general form would be something like b to the x. You might also see e to the x. Now, e we'll get to later. I'm not worried about that. E is an actual number, and we'll get to that later. But an exponential would look like this, b to the x, some number to the x power. And then you might have some other stuff with it, but you've always got the exponent as the unknown. So the variable, the x or whatever, is the unknown. And what that looks like on a graph, just in general terms, is it kind of looks like this. It would start right here, and then it starts building, and then it really just kind of shoots up like that. So that's what an exponential would look like generally. A log function would look like this. Log, and then you'd have like parentheses here, or you might see log base 10, and then x like that, and that would be like equals y or whatever. That looks like this. So that would come from down here, and it would kind of go this way. And if you remember, inverse functions, let me get a different color, they reflect or flip over the y equals x line. So if you look at the red function and you look at the green function, they kind of look like mirror images of each other. They're not great drawings, but they should be mirror images of each other if you've got the same function rewritten as a log function. All right, so that's just what they look like, and we're going to talk more about the graphs later. Today what we're talking about is the exponential statements and the log statements, and switching one from another, converting them. Okay, so if I said write each of these exponential equations as a log equation, here's what you're going to do. Let me get my highlighter again. So base, I want a different color. Now that'll be fine. Purple. Okay, so base, I'm going to just color all the bases purple. Okay, so all of those are going to go in the same place. My exponent, I'm going to highlight yellow, which I covered up some of them. There's my exponent. And then the other number that I really don't have a technical name for is this. So all of these things are going to switch to the same position in the log statement. Okay, so here's what we would do. We would rewrite this by first just writing the word log. The base always goes down there is called a subscript. Instead of being up like an exponent, it's down below the word. So the base goes there. And then this part that's in green, get used to putting it in parentheses. You'll be glad you did later. And then my exponent always goes after the equals. So my exponent, which was yellow, moved there. My base, which I did in purple, is down here. And then the other number is right here. So that's where everything moves to. Okay, let me tell you this. Base 10, sometimes you won't see a base at all. If you don't see a base down here, it's base 10. That is what we call a common log, or it's understood. If you don't have a base, if you just had log 1000, so you know what, we'll write that too. This could also be written log 1000 equals 3. So it could be written like that too, because if you don't have a base written down there, these are the ones you can put in your calculator. And so it is base 10. All right, number 2. So we would write log base 5, goes down there, and then the 125 goes here, equals, our exponent was 3. Okay, number 3, that would be log base 4, 0.25, and this is a negative exponent, and you might want to note that on a negative, or excuse me, if this is a fraction, so let's put right here, if this is a fraction, in other words, if it's between 0 and 1, your exponent is negative. Okay. All right, and then the last one. We don't want to write equals. We're changing it to log form. I'm not going to write equals. This one would be log base 3, and then 1/27th, and then that would be a negative 3. So I just want to talk to you about that a second. If you have a negative exponent, so 3 to the negative third power, if you have a negative exponent, well, 3 to the third power is 27. But if you have a negative exponent, that equals 1/3 to the third power. So that is why that 1/27th is there. So anytime you have a negative exponent. I also want to call to your attention that anything to the 0 power is going to be 1. So if you have like 6 to the 0 power, I think we have an example of this. 6 to the 0 power is 1. 8 to the 0 power would equal 1. X to the 0 power equals 1. Anything to the 0 power is always going to be 1. Okay, let me pause for a second. Yes, Grayson, I'm sorry. I can't see the chat box while I've got that up, but yes, you can do that. You can either do that or you can watch and then fill in your notes later, but I think it'd probably be better to try to fill them in as I go. I'm trying to go a little bit slower. Any other questions before I keep going? Okay, so that was changing exponentials to logs. So now let's look at the other way around. All right, so these are log equations and we want to switch them to exponentials. So I want you to remember that the 2 on this first one, the 2 is the base. So that's the first number we need. So we're going to rewrite this as 2. And this one, again, remember it kind of goes in a circle. So 2 to the 5th power equals 32. And it does. You can check that. You can put that in your calculator. 2 to the 5th power does equal 32. If you got something like 32 to the 5th power equals 2, well, it doesn't. So you can check yourself on these and make sure that, yes, that is a true statement. All right, number 2, I would write, and I'm trying to write a log, sorry. I would write 8 to the 1/3 power equals 2. Now, another way to write something, if you have a fraction exponent, this is the same as the cube root of 8. So something to the 1/3 power, 8 to the 1/3 is the same thing as the cube root of 8. 4 to the 1/2 power is the square root of 4. Let's see, what's another one? 27 to the 1/3 power is the cube root of 27, so that would be 3. So that's another way to write cube root, square root, fourth root, whatever. All right, number 3, I would write 6 to the 0 power equals 1. And we did actually just talk about that. 6 to the 0 power equals 1. And it does. Anything to the 0 power equals 1. And then the last one, number 4, 5 to the 2nd power, or 5 squared, equals 25. And it does, because 5 times itself equals 25. So that's how you can check those. All right. Questions about that before I move on? All right. If you have trouble with this, because you have to know how to rewrite these, you have to know how to rewrite the exponentials as logs and vice versa. If you have trouble with these, I have 2 IXLs I can recommend to you. These are not required, but you could go to IXL, go to the Algebra 2 section. And again, these aren't required. You can try R1 and R3. These are both really good resources just for practicing converting from log to exponential and vice versa. It is essential that you know how to rewrite these before you do the inverse, before you find the inverses. Okay, and that's what that says right there. All right, the next part of the notes. Hang on one second. Here we go. Okay, I don't have the directions on my sheet or my thing, so I need to just look at my sheet. Find the inverse for each exponential function, state the domain and range of both functions, and then of course it says you need to know how to rewrite. You do not need these graphs in your notes. I'm showing you what the graphs look like just for reference, and so we can find domain and range. I want you to notice that the red graph is the exponential and the green graph is the log function that we're going to come up with as we find the inverse of this. And I'm going to show you every step, but it also asks us to find the domain and range. So the first thing I want to do is look at this red graph. Y'all might not be able to see it really well on your Chromebooks, but I can tell you what it does and where it goes. So if you notice down here at the bottom, this graph kind of levels off, okay? So this is called an asymptote. What it's approaching is called an asymptote, and you should have heard that word in Math 2. If you didn't, this is what it looks like. So exponential and log functions have what we call asymptotes. What that means is it's a line that graph approaches, but it actually never touches it or crosses it. So where you see up here, you can see that it's still kind of going to the right as it goes up. But down here at the bottom, it actually approaches this line. Let me see if I can it approaches this line right here. But if you were to go on Desmos and graph it and like really zoom in on it, you would see that it actually never touches that line. And this line on the red graph is at -8. Okay, so when we talk about the range, we're going to talk about -8 being like the starting point. Well, let's talk about domain first. So the domain of the red graph, or of the first one, and we'll just put a D there to denote that, it does go forever to the left. So we're talking about left and right motion, remember? Left and right direction. So it goes forever to the left. So that means it does come from -infinity. And then it also goes forever to the right. So it goes to +infinity. Now, what we know about inverse functions, if you remember from last week, is inverse functions, the domain and range just switch. So I already know then, if the domain of the red graph is -infinity, +infinity, the range of this green graph is going to be the same thing as the domain. So they're going to switch places. Well, let's talk about the range of the red one. And this is the red graph right here. I just graphed this right here on Desmos. Okay, so the range of the red graph, again, it starts at this green line that I drew, and that is at -8. Now you might look at the equation of this and see that there is a -8 there, and so I could figure out what the range is by just looking at the equation. I wouldn't have to look at the graph if I know what the patterns are. So it starts at -8. It does go forever in an upward direction, so it goes toward +infinity. in the upward direction. So when I get down here and I get my log function, I'm just going to switch these two. I'm going to switch the domain and range. All right, let me pause for a second. Any questions right now? Excuse me. Okay, we'll move on. Okay, so let me say this one more time. The red graph, this is exponential. They're asking me to find the inverse. What that means is that I'm going to end up with a log function. So my statement down here in green is going to be log something, okay? So if you remember from last Thursday, if you watched the video or you were with me during the live lesson, you remember when we do inverses, the first thing we do is we change this f of x, or whatever this right here is, to a y, and then we switch the x and the y on the next line. So when I write the next line, I'm going to write x equals 5, and then the y goes up here in the exponent, minus 8. So it equals 5 to the y minus 8. So that's my next line. What I'm trying to do, I'm going to use my highlighter again. What I need to do is I need to isolate this part right here. So the part that has the variable, I'm solving for y, I need to isolate that part. Okay, so to isolate that, I'm going to add 8 to both sides. Okay, so when I add 8 to this left side, x plus 8, there's no other way I can write that but just x plus 8. So I'm going to write x plus 8 on the left equals, and then negative 8 and positive 8 is 0, so I have 5 to the y power. Well, that's what I said I needed to isolate. So I've got this all by itself. Once you have that part by itself, then what you're going to do is you're going to rewrite it. So on this next line, I'm going to rewrite as a log. Okay, so you don't rewrite it until you get this part by itself. So you got to do all your adding and dividing and whatever else you need to do to get that yellow part by itself. Now I'm going to rewrite it as a log. But for me, I like to turn this thing around first. You don't have to, but I like for my y to be on the left, so I'm going to rewrite it like this. 5 to the y equals x plus 8. So all I did was I flipped. I moved this over here and I moved this over here. And that's fine. Now what I want to do is rewrite it as a log. So I'm going to change colors. And I'm going to write log. The base is the 5, because it's 5 to the y power. And then in parentheses, what is over here on the right, I write that there, and then equals y. Okay, so let me talk about the parts again. So the 5 is the base. That goes there. The x plus 8 goes here in parentheses. And then the exponent, which is right there, goes over here. So we just did exactly the same thing we were doing with just numbers a while ago. And well, just one variable a while ago. So here's why we do that. Because if I have an unknown in the exponent, there's no operation that I can do on both sides that will get rid of that 5. So that's why I have to rewrite this in log form to be able to solve for y, which I just did. I solved for y. So because I have y by itself, sometimes there might be some other stuff with the y that I'll need to continue with the problem. But I got y by itself. So if y is by itself, that's my answer. What you can do is you can go back up here and write the original, the f. You can write it in inverse notation. You don't have to, though. So for me, this is fine if you leave it like this, or you can do your inverse notation. It's exactly the same. I just turned it around. Now let's talk about domain and range of this green graph. The green graph has what we call a vertical asymptote. So where this one up here had a horizontal asymptote, a log function always has a vertical asymptote, which is right here somewhere. It's also at -8. So the vertical asymptote on the bottom graph, same thing as the horizontal asymptote up here. I don't really care that you know all that. I just need you to know that what I'm going to do down here when I do domain and range is I'm just going to switch these, like the range of the red one is the domain of the green one. So just switch them. And then the range of the green one is the domain of the red one. So that's negative infinity. And we could go through and we could look at this graph and we could talk about that. But all you need to know is just you switch them. Okay. I know this is very new and we need more practice, but do y'all have a question about what I just did? You probably don't even know what to ask right now. Okay, let's look at a couple more.
Wait, hold on.
Go ahead. Yeah.
I'm still lost on anything, really.
Okay, let me do another one, and you make sure that you're writing down what I'm writing, or you can write it on paper, or you can do it on your PDF. But let me do another one and keep talking about it and see if it kind of comes together. Okay. All right. I understand. I know this is a lot. Okay. So I'm gonna talk about this one. Okay. Yeah, we'll go ahead and do this one. I might change a couple of them up a little bit, make them a little bit simpler because it starts to get really complicated towards the end. All right, so look at number 2. And I might actually tell you, cross this one out. You don't have to do this one or whatever. Okay, so inverse functions. First thing I want to do is, and I'll write this down, I want to change f of x to y. Okay, so I'm just gonna write over it. I'm just gonna make a y. Okay. Second step, switch x and y. So rewrite it on the next line, make this an x equals. And then just rewrite that whole thing, 3 to the y minus 9 over 3. So that's the next thing you do. Okay. Now what I'm going to do is I'm going to highlight the part that I need to get by itself, okay? And that is going to be this part right here, the 3 to the y. I need to get it by itself. Okay, so my next step, I'm going to write this too. Next step, isolate the part with the variable. Or let's say with the y, because there's more than one variable. There's an x too. So isolate the part with the y. All right, I'm going to take this out of parentheses. I'm going to get rid of these parentheses. I'm just going to erase them. I don't need them. So I want us to look at this, 3 to the y minus 9 over 3. Three to the y, I need to get that by itself. Well, what was done to it? 9 was subtracted, so it was a minus 9. And then this fraction bar means divide, so we divided by 3. That's the next thing we did. So I need to undo those steps, okay? So when I undo those steps, I need to undo them in the reverse order. And we talked about this last Thursday. So what I need to undo first is this part right here. The opposite of divide by 3 is times 3. That undoes the divided by 3. So if I multiply times 3 over here, and I multiply times 3 on this side, this becomes a 3x, 3 times x, 3x equals. And then what happens over here is these cancel each other out, and I have 3 to the y minus 9. Okay, so I took care of this step right here. The last thing, or the next thing that was done, or the first thing that was done, was the minus 9. Somebody tell me, what is the opposite of minus 9? You can type it in the chat box if you want to. I can see it. What's the opposite of minus 9? Is it divided by 9? Times 9? What's the opposite of minus 9? Good, add 9. Thank you, Johnny. Yes, add 9. So now what I need to do is I need to add 9 to both sides. So plus 9 here, plus 9 here. Now, 3x plus 9. I can't add the 9 and the 3 together. I'm not going to multiply them together. So the only thing I can do is write 3x plus 9. And minus 9 plus 9, that's 0. So now I've got a 3 to the y on the right side, and I've got 3x plus 9 on the left side. The problem with these types of problems is that they don't turn out to be like one number. Like when you're solving an equation, you kind of get a little bit of satisfaction because if you get that one number at the end and it's a whole number, you're like, okay, I think I did that right. The problem with these is that you don't really get that at the end. You're left with this big, long set of numbers and you're not sure if they're right or not. So, I mean, I get that, but this is how you do it. Okay, so I have isolated the part that I said I needed to isolate, this part right here. So this is the point. So this would be step 4. Step 4 is rewrite as a log. Okay, so I'm going to rewrite this, excuse me, log, the base is 3, because that's what's been raised to whatever power that is. The base is 3. The part that goes in parentheses is the 3x plus 9. And then equals, the exponent goes right there. So I didn't rewrite this. I didn't turn it around. Sometimes I'll turn it around and I'll write 3 to the y power equals 3x plus 9. I didn't do it that time, but if you need to do that, it's fine. So base, the base is 3. That goes there. The exponent goes here. And then the part in the parentheses goes right there. That's all we have to do. This has been changed to the inverse. So I can rewrite it if I want. You don't have to. You can leave it just like this. But I can rewrite it as, it started out as g to the x. Okay, so that's the answer right there. And if you went over to Desmos and you graphed this, you would see that orange graph over there. The blue one is the original. The orange one is this log function down here. So they are kind of mirror images of each other over that diagonal line. And the domain of the blue one, let me see what that one was. I'm just going to give this to you. The domain of the blue one, and I meant to change colors, is negative infinity, positive infinity. The range was -3, positive infinity. Okay, so if I go to orange, oh, there's no good orange color. That'll work, I guess. The orange graph, which is this, the domain is the range from this one, -3, positive infinity, and the range is what this domain was, negative infinity, positive infinity. Okay. I know it's a lot, and I'm trying to make it as easy as I can, but we need to go to the other type of problem too. So I'm going to do one more like this, and I think what I will do, I'm going to simplify this next one a little bit. So when you look at the next one, I want to take out the 1/2. Don't worry about that part. So we're going to do it like this, and then these graphs actually are not going to apply, but it doesn't matter. So we're just going to do, I'm going to rewrite it. H of x equals 4. I'm going to rewrite the whole thing. 4 to the 3x minus 5. Let's do it like that. Y'all come into the live lesson. Sometimes I'm going to shorten stuff. I'm going to show you another way to do something. You know, make it simpler or whatever. And I also did a help video for your classwork for today. So you'll be able to look at that. And I did all but like 2 of the problems for you. So, okay. Okay, so if we look at it like this, what I need to do is rewrite this, change this to a y. Let me get a different color. Change this to a y, and then switch the x and the y, if I'm following those steps. So this is going to be x equals 4 to the 3y minus 5. Okay. If you look at the steps, I need to switch the x and the y next. So I did that, I'm sorry, not that step. Sorry, I did that already. Isolate the part with the y. So I need to isolate this right here? Well, then what I need to do is I need to get rid of the minus 5. Well, to get rid of minus 5, I'm going to add 5 to both sides. So x plus 5 equals 4 to the 3y, because that gets rid of that right there. So I've isolated what I need to isolate. Now, again, I like to rewrite this. I like to have the part with the exponent on the left because it helps me to see how to rewrite it. Okay, so now what I need to do is rewrite this as a log statement. So log base 4, and then the part that goes in parentheses is the x plus 5 equals 3y. Okay, so when I did these before, once I rewrote it as a log, all I had was y by itself. So you can see that one, and then this one I had y by itself. So on this one it's a little bit different because I've got a 3y instead of y by itself. So I'm still trying to get y by itself. I'm still trying to isolate the y. So I need to do something to both sides to get y by itself. Well, it's multiplied times 3. So just like a regular equation, I need to divide everything by 3. So when I do that, that gets rid of that, and I have y by itself. And I just rewrite this whole thing. There's nothing else to do to it. I just have to rewrite it. So this is the answer right here. And if I were to graph that on Desmos, I should see one of them going one way and one of them going the other way. All right, everybody's still with me. That's good. Nobody left, so that's good. I'm going to give y'all the Google form one more time because we've got about like 5 or 10 more minutes before I stop. Let me talk to you about this. Some of you are probably like, I will never get this in my life. I'm so lost right now, I don't know what she's doing. I understand that. What I need you to do is I need you to do the notes like I'm doing them. I need you to get the classwork done. I'm going to give you a link in a few minutes to a video where, first of all, your classwork, I marked out a bunch of them. So when you go to the PDF for the classwork today, you should see where I've marked through several of them with a red line. So you don't need to do those. You only need to do the ones that are not marked through. Also, if you go by that video, I'm getting ready to give you the link to it. I'm going to give it to you in the chat box. You will have all but, I think, 2 of the problems done for you. So all I need you to do is just try those 2 problems, okay? And then come back tomorrow and I will go through those 2 problems with you as well. I don't expect you to completely understand everything that we do in this class. It's just not going to happen. Look, when I started teaching this, I had to study this stuff because I'd never taught high school math. So I had to study it. I had it way back when I was in high school. I'm old, y'all. It was a long time ago. So I understand if you're like going, yeah, I'm not going to get this. It's okay. Because if you do the work that I ask you to do, you're going to pass my class. I've said this from the beginning. We are starting the 5th week today. And so if you do what I ask you to do, you'll be okay. Okay. The other thing that I usually do is on test review days, which we're going to have on Thursday because you have a test on Friday. What I'll typically do is I'll go through some review questions with you. And what you'll find out is that some of those review questions, if not all of them, are actually on the test. So if you pay attention and you show up, you're going to be okay. And a lot of you have already figured that out. Okay. All right. So I'm going to go through, let me see where we are exactly. I don't know if I've got another one like this. I do. We're going to skip this one. I may come back to it tomorrow, but skip number 4. And so here we are with log functions that need to be changed to exponentials. Okay. So on these problems, it's just kind of going in the reverse order, or not reverse order exactly, but we're going from a log function to an exponential function. And what I need to do on these is I need to isolate this part right here. So isolate the log and then whatever it says right there. Now, because there's no base here, it's a 10. There's no base stated, so I'm going to write in a little 10 there. So the base is 10. So if it's not stated, that's just what it is. Okay, you know what, let me get a purple because that's what color that graph is. Okay, so you want to isolate this part, and then you just rewrite this with a y right there. Let's rewrite it. X equals log base 10 and then 2y. Okay, so I need to get the 2y by itself, but I'm ready now to rewrite this as an exponential, because if I don't have anything else outside what I highlighted up here, then I can go ahead and rewrite it. But the first thing I want to do, because I like to write them like this, I like for this part to be on the left. So I'm just going to switch everything around. Equals x. Okay, so now I'm going to rewrite it as an exponent, as an exponential statement. So the log word is going to go away. Let me get a different color. Since my graph is black here, I'm going to do it in black. Okay, so if you remember what I did earlier, what you do is you take the base and you take it to this power. Okay, so 10 to the x power, and then it goes in a circle, equals 2y. Okay, still trying to solve for y. Solve for y. Okay, so y has been multiplied times 2. So I just need to divide by 2 on both sides. So this cancels. Y equals 10 to the x power divided by 2. That's it. I can't simplify this in any way. This is my answer right here. So we can rewrite like v to the negative 1x if we want to. I don't care if you don't do that. 10 to the x over 2. That's the answer. I'm not worried about domain and range right now. We'll talk about that later. Let's look at another one like this. Okay, so let me show you what has to be isolated. I'm going to highlight it again. This part right here, the log, the base, and the part in parentheses. So I have a negative 7 I'm going to have to get rid of in a second. But the first thing I want to do is I'm going to change this to a y and then switch the x and the y. So I'm going to write, I'm sorry, that's wrong. X equals negative 7 log base 6, and then I don't need parentheses right there. I just put them in the wrong place. Okay, negative 7 log 6 negative 3, and then we put a y there instead of an x. So what part do I need by itself? Let's highlight it one more time. I need this and this by itself. So the negative 7 is what I got to deal with first. This has been multiplied times this. So if I divide on both sides by negative 7, then this will be isolated. So that cancels. So x divided by negative 7 equals log base 6 negative 3y. This is isolated, so now I can rewrite this as an exponential statement. My base is this. My exponent is this. And the part that goes on the right of the equals is this. You get a blue. Okay, so I'm going to rewrite this. 6 to the x over negative 7 equals negative 3y. I'm almost done, but I still need y to be by itself. So what I need to do on both sides, and this one's going to end up looking really weird, is I need to divide by negative 3. Those cancel. Y equals, this is just a big fraction, 6 to the x over negative 7. Oops, 7. My pen doesn't want to work. Over negative 3. And you leave it like that. That's it. All right, on the notes, I want you to mark this one out. Mark this one out. And then I think that's it. Yep. Okay. Let me pause this a second.